Today we're starting our new unit, and we kind of shuffle things around a little bit in the order in which we're doing things, specifically because it kind of makes sense to figure out where data comes from before we start talking about how we display it. Right? A little bit. Plus, I realize now how wonderful it was to have given you like the 1-2-page flip book first. And so now everyone's like, oh, it's just 1 page. I think so. There might be one more, but it's like half the page will be pre-printed for you. Yeah, you got more note cards this time. And the note cards this time I think are like really, really self-explanatory. Please make sure when you do this that you set it up like we have up here so that the title is visible so you know which card you're looking for when you're going for it. And then on the front needs to be either a definition or an explanation or a list of things that you have to have for that. And then on the back is always going to be an example. Okay, so that's the goal. The purpose behind this is so that you can say, I need to build a conditional distribution. So you flip to that card and you look on the top and it tells you what you need. And then you look on the back just for a little bit more emphasis to say, okay, what was that actually going to look like? Okay, that's the whole point of this. It's a great study tool. I like the idea of flashcards, but for me, flashcards get irritating because I'm looking for one. Where is it? It's like, oh, wait, I know I have this somewhere. And you're flipping through like a bajillion flashcards just to try to figure out what that one said. So it kind of merges the worlds of notes and flashcards together. Anyway, this unit is about displaying and describing data of all kinds. Chapter 2 is specifically about categorical variables or qualitative. So we're talking about things that fall into categories. The third unit is all about, actually 3 and 4 is about the quantitative stuff when we have numbers. Okay, and then the 5th unit is going to be our normal curve. Our 5th chapter is going to be normal curve. Okay, pretty straightforward. Here we go. So one of the main things that I want you to know is what you should have on every single display you ever draw. And this was in the video as well. You need to make sure that you always label your axis. Some variables or some graphs will only have one axis, such as the box and whisker plot, or if you're talking about the stem and leaf plot, you typically just have one axis. Otherwise, we usually have multiple. You always want to make sure that you identify what's going on those axes. Okay? Sometimes that includes talking about what your measurements are, setting your scale. Now, please understand, a lot of people have issues with this. Even if we're talking about percents, you do not need to start from 0. Okay? Percents, we typically do start from 0, but we don't always go up to 100. Especially if we're just drawing bar charts where it's just a piece of that 100. Okay? Sometimes when we zoom in on graphs, you might not see that bottom for percents even. And sometimes that's okay, but other times it makes the difference between groups look larger than they actually are. It's kind of like when people say, hey, look, this one's 99, 98, 97, 95. Look at the big difference between the first one and the last one. Like, okay, not much of a difference, but all right, whatever you want to say. And when you mark your measurements, make sure that you always give me your units. Okay? It's also about everything we do, we have to keep it in context. And the units talk about that. Now, the title itself is kind of like using some of your W's. Who is being studied? Who are your experimental units? What are you recording? Okay, if you have numbers, because we're going to talk about the difference between sampling from a small group versus the distribution of an entire population. So if you have a sample, you need to include that sample size. But then again, context, context, and context. Because with everything that we do in here, if we don't put context into what we're doing, it's absolutely pointless. And you're going to see, I don't know if it's this, it's unit chapter later on, where literally leaving out one word completely changes the entire meaning of the whole problem. Okay? You've got to be very careful with that. All right, so in the video, we talked about, what did we do? We did bar charts, segmented bar charts, pie charts. Was there any others? Did I do any of the others? Bar charts, segmented bar charts. I think those were the main three, right? Where we talked about what you needed to have for each of those. A mosaic plot is something that the AP is including new this year. But the mosaic plot is a really cool descriptive type of a graph. Okay? Basically what it is a segmented bar chart. So you go from 0 to 100%, you go from 0 to 100%, everything is 0 to 100%, and you're breaking it up. So sometimes we think about it as multiple segmented bar charts, but it's really kind of interesting. And basically what I need to make sure that you understand here is this says that both axes are relative. What does relative mean? Heard it? What? Percents. Your axes must be in percents in order for this to work. And we're not looking at the area that's represented in a box. We're looking at one dimension at a time. So we're looking at either the width or the height. But the area kind of invalidates something that we call Samson's paradox, which is I can double the height, but if I double the width at the same time, I've actually multiplied that entire area by 4. So you want to be really careful about that. So here's an example. A lot of times we want to look at a group of individuals and see how they break down into smaller and smaller and smaller subsets. So here, all of this, we're talking about people, and we're identifying those people primarily based on their education levels and on their age. Okay? So I'm going to have high education, low education, which is probably above high school, below high school, or high school and below. We have old and we have young. But we wanted to take it a step further because our goal here was to examine the distribution of people who listened to classical music. These are all things that might play a part. It might play a part in whether you are older or younger, how much education you've had, and all of this kind of relates. So how we build one of these mosaic plots? You start with everyone. Makes sense, right? Graph's got to incorporate everybody. So you start with everybody, and then you make your first division by whatever that primary topic is. So we were looking primarily at the old folks and the young folks. And so what we're going to do with this is we are going to break it down from left to right based off of proportions. So if I have 60% old and 40% young, I'm going to break this axis up into 60-40. And I leave a nice kind of wide box between this so that I know I can actually see the group separations and it's not going to get as confusing for me. So that's my first group. Then we break it up again by our second group. So maybe of the old people, I have only, let's say 20% are highly educated, where the other 80% have low education, where for the young folks that I've interviewed, somehow I have 55% that are going to be high educated and 45% that are going to be lower educated. Do you see how this is starting to break down? Once I make a break between my groups, I'm just going to keep working in those smaller subgroups. Okay, so I started with old and young, and once I did that, I find the proportions for each of those. Now, what's really cool is I can go a step further with this and break up each of those groups. And I can talk about whether or not they listened to classical music. They choose to listen to it. So you can see this box represents, if I go across here, of those highly educated, if I'm reading left to right, I can see the proportion of people who do and who do not listen to classical music. It gives me that percentage going left to right. Vertically, I can see the percentage of people who are still, I can see that big group, but I'm not going to cross where these groups kind of like break down, the bigger spaces between them. Does that make sense? And these are all proportional. So I can see here that my smallest group proportionally, we're going to look one direction or the other, not total area, is going to be, let's see here, young people who listen to classical music that are qualified as low educated. Because in both directions, it's the smallest group, proportionally. Okay? That's our Mosaic plot. And you can keep going with those things as far as you need to go. But basically, you divide an entire group, pick one classification, proportionally divide it by that classification, and then within each of those boxes that you've now made, you're going to take the next classification and divide it proportionally by that one. And then the next one, and the next one, and the next one. You can go as far as you need to with these. But they're kind of cool. Yeah, kind of looks, get the term mosaic, piecing them together. We spread them out so that we can tell what's what. That's generally a mosaic plot. Now, when we're talking about categorical data, we're focusing on usually what are called contingency tables. Now, a contingency table, it's a little bit more narrow than a mosaic plot because a contingency table has two categorical variables. Two. Categorical. If you don't have two categorical variables, it's not a contingency table. Okay? So what you're going to do with that is it allows us to look at how individuals are distributed among both groups. Now, our textbook loves the Titanic as an example because it hits everything. You kind of get to see, all right, well, we're looking at survival rate from the Titanic. Did more women survive than men, proportionately speaking? Did more older people or children? Was it by class? What have you guys heard? When you think Titanic, women, what? Women and children were saved first. Did it matter what class they were in? Yes. Who got saved first? First class women and children. Okay? Then they kind of filtered down. And even before they got to the third class women and children, a lot of the first class men were already getting on the boat. Okay? And being able to break this down into first class, second, third, crew, and look at their totals, we can examine that at a closer look. Now, don't think that this was 100% prejudice to people in first class. Understand, typically, where are the crew in a ship? Below, in the bowels. And so if you've got an issue where you have flooding within the ship, they're going to be the ones that find it most difficult to get up anyway. So it's not like we locked the door on the crew members and said no. Okay, we're going to have some that are up working the tops. They're going to have a better chance than the ones who are all the way in the basement. Same thing with third class. Typically, as you go down in classes, you actually go down in the ship. And so that's going to make it harder to come up. All sorts of these little things, confounding and lurking variables, played a role here. But this is a contingency table. And you can see here that we have individual cells with counts. So that's this one here is the number of people who were alive in first class. This number here is the number of people who died from the third class. These are your totals for each group, and you see totals going both directions, and that is your total. It's your grand total. Now, don't be tempted to say 711 plus 1490 plus 325 plus 285. Don't do that. Because if you do that, you're counting everybody twice. Because everyone shows up someplace here, everybody shows up someplace here. So that's our contingency table. Now, in contingency tables, we like to kind of break it down a little bit more carefully. And we have margins. Where are the margins on your paper? On the sides, right? Marginal distribution are the sides. Here's the marginal distribution for that category. It tells me how was this category overall broken down. So of the alive, I had 711, and of the dead, I had 1,490. There's another margin down here that's also a marginal distribution. And basically what that is you say you find your totals, and you find which group that's parallel to, and that's the marginal distribution of that group. Edge to edge, top to top, bottom. Okay. So the cell gives the combination. We talked about that already. Okay, so keep going on with this. There's conditional distribution. And when we do our probability unit, you're going to notice that conditional distribution, conditional probability is a very specific thing. And basically what it's saying, I don't care about anybody anymore. I'm just caring about this one group. And in this one group, I want to know what the percentage is. So conditional distribution picks one variable, and then it looks inside that variable to see what happens. So, and you can see here, it's the cell divided by one row or column, depending upon which category you're looking at, total. So if I'm looking at the conditional distribution of those that are alive, that means I'm only looking at those that are alive. That's my condition. I'm viewing my window in on that. And I'm going to find the distribution here. You can do it either by counts, but we typically go with relative frequencies because these totals, the grand totals for each section are different. And so we take the cell divided by that row or column total. So this is the conditional distribution of alive. What percentage of the alive people were first class, second, third, and crew? And I want you to listen to what I just said. I said, what percentage of the alive? If you ever see the words of the, that's a conditional distribution. And whatever follows that, that is the group that you're just looking at. Does that make sense? So then this is the conditional distribution of the dead, or of those that died. I'm just looking at that group, and then how those percents broke down within that group. Okay? So this is a mosaic plot for the Titanic. Yeah. And please, AP has said that this is going to be one of the topics. I don't think they're going to ask you to build a mosaic plot. I'm hoping they don't. Nobody really knows. Like, yay, no one knows. But to be able to interpret it is very important. So if I look here, I am going to see across the top, my biggest groups that I'm dealing with are children and adults. So I've got the classes, first, second, third, and crew. And within the classes, I broke it down by children and adults. That was my first grouping. And I can tell that that's my first grouping because that's where all of my lines continue to go. You see what I'm talking about? First, we grouped by class, crew adult, third adult. You can see there. And then inside it, I took the children to the left and the adult here. And I can see that that line goes all the way through. So my first distribution breakdown was based off of what we're talking about here, which is class. And then within that, I broke it down by child and adult. What did I break it down by next? One more time. Sex, gender. So I look at this one block, and you see where is the next nice divide. Going horizontally. This next block, horizontal. This next block, that's where it cuts through both of them straight across. Okay. Then, after that, they broke it down. Let's see here. So we have male and female, and then we have at the very end, survival or not. So I can see here, and this should kind of make sense. What do you think those three dots right there in the bottom mean? 0. Means if I had a line there, that's where it would be. But how many of the crew do you think are going to be children? I mean, it was a long time ago, and they did have, like, child labor issues. But they're not going to be down in the bowels of a ship. 0. We also have 0 for my non-survivors, male and female, for first and second class. I got all of the first and second class kids out. And I can see that here for my first and second class. I see very, very narrow groups, and those are my dots. So here's a dot here. There's a dot there. There's a dot there. There's a dot there. So these graphs just tell us a whole bunch of broken down information. Okay? All right. So more on our conditional distributions. We can look at our conditional distributions and determine whether or not there is an association going on. Does it matter if you were first class or crew what your survival rate would be? Did your survival rate depend upon your class? We can ask that with conditional distributions. And I don't care how you do it. Pie charts, great. Back in the day, pie charts sucked. You want to know why? Because you literally had to find angle measurements, draw circles, measure the angle measurements, get them perfect, and it was like, give me a box. I can break a box down super easy. Don't make me do a circle. But nowadays, you throw it in Excel, you say, click the boxes you want, and you say, make a pie chart. And life is all of a sudden easy. So I don't care which way you chose to do it, but if we look and I compare the alive to the dead by colors, do you think those proportions are going to be the same? The percentage of the alive that were in crew versus the percentage of the dead that were in crew. Looking at these, do those graphs look the same? No. Just by looking at them and saying, dude, those are not the same, that should be this red flag flashing in your face. Hey, they are not independent. If they look identical, we can say independent. But those are not identical. So I would say survival is not independent of class. Just by looking at that picture. Okay? So you can use the word associated. Typically what we're going to do, we're going to focus on the words independent and then just not independent. Because associated can sometimes get a little bit confusing as we work through all of this. Okay? So when we go through, and if I have a contingency table and I find all my percentages, and if I'm comparing one group to the next group, those percentages, and generally my rule of thumb for where we're at here is I say within 2%. If all of your groups are within 2% of each other, you should be okay. But I say all of their groups because I can have 3 groups within 2% of each other, and then the last group is off by 6%. Do you understand how those kind of balance out? So if everything is within about 2% of each other, we get to say that they are independent. Otherwise, we say they are not independent. And I don't know why there's a plus sign at the bottom of that. I don't know, whatever. All right, so in your notes, and I greatly apologize. I have no idea how this happened. You look at the copies I sent down, and they were all normal pieces of paper. And yet, everything got printed in landscape. No idea how. Sorry about that. I looked at it and I went, what? But again, with this unit, you're just like perfectly seated. I'm going to remind you all, you have your outline, what we're doing each day, when your quizzes are. You'll be able to put the quiz dates on here. I don't put them on here because you never know what happens. You can see what your assignments are. And with this chapter, we get to go a little bit more broad in Khan Academy. So rather than going into specific lessons and saying do this lesson, do this lesson, do this lesson, we do what they call quizzes and tests, which incorporate multiple concepts. And that way we keep it about 20 questions per assignment. Kind of keeps it more level. And basically everything you need, you will see on there. And then on the second page, printed in a lovely landscape fashion, don't know why, is your rubric for the flip books. Okay? And understand as we go through these, neatness is going to count for less and less because hopefully as we go through this, you start to figure out, you put tape across the top, you line up the cards on the lines on the page. And 3x5 cards are standard sized cards. And if I can't read it, I can't grade it. Okay? All right. So here we have a pretty relative or important topic. Is there an association between smoking and your level of education? So what I want you guys to do with this, I want you to go through problems numbers 1 and 2 for me. Describe your W's and identify your variables. And when we identify your variables, I want you to tell me if it's categorical or quantitative. Okay, go. So let's talk about the W's. What are my W's? Who? 200 adults at a shopping center. Do we know where that shopping center or shopping supermarket, where that was? No. So we can't say the specifics as to where. I just know it's some supermarket. Who, what, do we know when? Not a clue. What, when? We already said where. What? What did I record? There you go, 2 things. 2 whats. 1 on each axis for my contingency table. My first what? And I don't care which way you look at it. Education first and then smoking, or smoking first and then education. Either ways, they're asked those questions. So those are my whats. Why? Why would I ask these questions? Yeah, we want to see if maybe education has any impact on your likelihood of smoking. Did they come out and say that's why we're doing this? No. You should still be able to do what's called inferring. Educated guess. Using the information at hand, why do you think somebody would do this? I'm not going to ask them if they smoke and what their education level was, if I just kind of, I don't know, want to meet new people. It'd be a very interesting way to meet new people. Please don't try that. Okay? Better choices. Who, what, when, where, why, and how. How is that data collected? What do we call that? A survey. Do you understand? Now we're to the point where we're talking about how do I get this data? That data was gotten. It wasn't an observational study. I didn't just sit there and say, I'm watching you. They asked. I didn't put treatments on them or anything like that. I just asked. So, the W's, pretty straightforward. 200 adults, where we were recording education level and smoking habits. We don't really know when, and the best thing that we can say is a supermarket or a shopping mall. How? I mean, it's some survey of some kind. I don't know how the people were selected themselves. And to look to see if there's a link. Okay, tough question. What are my variables? Give me one. Age. Well, not really age. Level of education. She's like, that's what I meant. Come on. Level of education. What do you think? Quantitative or categorical? If I ask you, what is your level of education? Am I going to get quantitative or categorical? If I'm doing a contingency table, it has to be categorical. I'm basically saying, which one of these boxes do you fall in? Yay! And a lot of people, when they're gathering their data here, they simply put a tally mark wherever that thing belongs. I am a smoker with a high school education. 1 tally mark right there. Okay? All right, so, and then there is, so my first category, my first variable was education level. What's my second one? Smokers. Is that going to be qualitative or qualitative or categorical? It's the same thing. Or quantitative? Again, categorical. Because in order to do this, you have to have 2 categorical data that we're looking at, 2 overall categories. So those are my categories, and they're both categorical. All right, now the interesting thing about number 3 is they're all talking about smokers, high school. Do you think all 3 of these are going to be the same? No. And this is where things get a little tricky. You've got to read carefully. What percentage of the shoppers? Who am I talking about? The whole joint, all of them. So what is my total of the shoppers? 200. That's my denominator. Of the shoppers means the denominator is the number of shoppers. That sound weird? No? Okay, I was like, did I say something strange? Because it usually is me. So, what percentage of the shoppers, whatever follows the of the, is your denominator. And then I'm going to look at smokers with only a high school education. What number represents that? 32. Because of the shoppers, that's my total. For smokers with only a high school education, that's 32. So how do I find that percentage? 32 divided by 200. Hey, guess what? This is statistics. I don't care if you simplify that fraction. In fact, please don't. Did I just say that? Did I just tell a group of math students not to simplify a fraction? It's actually better not to simplify your fraction because then we can tell exactly where your numbers came from. Okay? You don't even need to divide unless you want to. But if you divide, be careful. You're going to take a decimal out to 4 decimals, or stuck a percent sign in there and you take it out to 2. Do you see how those are the same thing? 4 decimals for just a probability, 2 decimals for a percent. Okay? All right. What about if I said percentage of the shoppers with only a high school education were smokers? 32 over 93. Because if I'm looking at this, this says of the shoppers for the first one, then the word were. So my total group is the shoppers. This one says of the shoppers with only a high school education, then the word were. So my total group that I'm looking at here is the shoppers with only high school educations, and that total is 93. Do you see what I'm talking about there? After the word of, before the word were. That's your group you're looking for. And then the 32 goes over that. And it says what percentages of the smokers had only high school educations? It's going to be 32 over 50, because this one, of the smokers, had and were are the same basic thing. So of the smokers, that's my group here, the total here is 50, had only a high school education. And so with your answers here, you're welcome to, again, leave them as fractions. Hey, why not stop there? Don't create more work for yourself. Or you could put it into percents, and if you're doing a percent, the textbook doesn't necessarily always follow AP grading standards, but for stats, we always take percents out to 2 decimals, or you could have left it as 0.16, 0.344, 0.64. Okay? So now what we're going to do is we need to make a picture. So in order to make a picture of this, you need to decide what is your axis that's going to be, because I'm doing a segmented bar graph, I want to know what axis you want across the bottom. Which category do you want? Education? So if I choose education, how many bars do you need? 3. Does that make sense? If I were to have chosen smoking preferences, how many bars would that have been? 2. Did they specify which one? All they're saying is comparing education level among smokers and non-smokers. So you pick, and if we're doing a segmented bar graph, it was very clear in the other video, what do we need for doing segmented bar graphs? It must be relative. It must be in percents. Okay? So what that means is you are going to look at each of your groups, and you're going to, if you're looking at the education, so you're going from left to right across that table, you're going to turn all of those guys into percents based off of your education level. If you're doing smoking, you can do your percents that way, so you can figure out how you're going to draw your graph. Go for it. Come on. Hi. Wake up, little Susie, wake up. I think I've stated before that I'm lazy. So I like to look at it and say, well, which one requires me to draw the fewest bars? So I chose to draw mine based off of smoking. But either way, you get the same general idea. And all I need to do is I need to say, is this pretty much this? Do my bars match? No, not even close. Okay, so it's going to lead us to our next question. But I want you to look at what this bar graph or this segmented bar chart has. Each bar goes from 0 to 100 because a segmented bar chart has everything on one bar. That means starting at 0 and going to the top of 100. They're set out of 100% because my total number of smokers and non-smokers was not identical. That is an absolute requirement. That's very important. You guys hear what I said? If your totals are not the same, total number of smokers and total number of non-smokers, you must do a relative frequency. You cannot do counts if your totals are not the same. It's the only time counts are acceptable on a graph. Okay? Either you're looking at just one category or your totals for your groups are the same. And then I look at this, and the way mine's broken down, I have my axes labeled. So I have my percentages. Note the fact that it actually has a percentage symbol next to each of those. Okay? I have my categories labeled. These guys don't have units. They just are. And then I have my title describing what I'm talking about here. Now, for this problem, I don't believe we got detailed information. There it is, 200 adults. So I would have actually preferred to have seen on my graph 200 adults and their smoking / education. It's your title. It's setting your context. Because there's a big difference asking 200 adults versus if I wanted to ask 200 teens. Those populations of interest are going to be completely different. Everybody okay with that so far? All right. So if you had education across the bottom, how many segments should you have in each bar chart? Just 2. And then this one, the way this is done, I have each piece labeled directly on the bar chart. If you don't, what do you think would be important to have? A key. A key, a key. That means something, right? It means what? Here? Oh, because I have no idea. German. I know German. I don't know anything else. All right. So this is a very important question that we will go into in depth later on in the year. Right now, we're just kind of tipping our toes into it and saying, do we have a suggestion of an association? Remember, association means not independent. We're not saying your education level causes whether or not you smoke. Your education level does not determine your smoking status. But is there some kind of a linkage between the two? What do you say? Sure. And I want you to look at that last sentence. Give statistical evidence to support your conclusion. That means, give me numbers. Do you understand what I'm talking about? So, you've calculated your probabilities broken down. So you need to look at them and say, find the most glaringly different probabilities between your two groups. So if I go back here, I would say, if I could either pick and compare high school to college, high school smoker to non-smoker, I could do 4-year plus college between the two, because those are obviously not the same. I probably don't want to compare 2-year college attendees, associate's degrees. Okay? If you're looking at education as your main breakdown, I would want to look at where the differences are the biggest between them, because you should just have 2 sections. Where's the white section smallest and biggest? And you want to actually give those percentages. So based off of my graph, this is how my justification works out. We do have evidence of an association. And we're going to use that term a lot. Evidence. I'm not saying abso-freaking-lutely one causes the other. I have evidence to support the claim, or I have evidence of an association between smoking and education level. Now, if I'm going to say association or not independent, all I need is one example why it's not. So I could have stopped saying 64% of smokers had only a high school diploma, while 40.7% of non-smokers had only a high school diploma. I would say those two are not equal. But do you see how I have numbers in context? That's hugely important. Or you could have done the 26% of smokers had 4 more years of college compared to 48 of smokers. Find your glaring differences. Now the flip side to this, if I were to say they were independent, it's kind of like proof. When I do a geometric proof, you guys heard of a proof by counterexample? It's like, is this true? No, look, here's an example. That's what we just did. Is that true? No, look, here's an example. But if you're going to say that it is true, you have to prove that it's true for every single case. So that means if I wanted to say that they were independent, I'd have to give me each of my pairs. You'd have to have 3 pairs of data. This is this, well, that is that. This is this, well, that is that. This is this, well, that is that. All within 2%. So does this problem indicate that if you start smoking in high school, you give it up by the time you complete college? Why not? Yeah. Because we're not really looking at people over time. We're just looking at flat-out groups. I'm asking you right now, are you a smoker? As of this moment, yes or no, are you a smoker? And then I'm going to ask you, as of right now, what's your highest level of education? If I was a smoker in high school and college, but I've since quit, what category am I going to fall into? Smoker or non-smoker? Non-smoker. Okay? So you need to kind of be aware of that. So it doesn't talk about the timing of when someone started or finished smoking, or if they did finish. All I have is yes or no questions. Okay. So we've done good progress so far. I want to talk really quick, and then I'm going to give you guys a practice problem. Y'all have something for this chapter called the Class Data Project. Okay? Guess what it's about? Data from your class. So in order for this to work, it's 2 parts. Number 1, you guys need to go on Canvas. There is a link to the Class Data Project form. Now you are going to put in your first and last name, but the only thing that's ever going to show up for is on my screen so that I can tell whether or not you did it. Beyond that, I don't care, because you're going to put things like height. I don't know if you're going to put weight in there or not. You're going to put things like your GPA, favorite colors, favorite subjects. You're going to put all of these different things in there. Understand what I'm talking about? I'm just going to put it in there and you're going to submit it. That's going to be the first thing. I want that done no later than Monday. Monday morning before school. I want to come into class and have that done. Because after that, what we're going to do is we're going to go into all of our topics and we're going to break them down. And you're going to pick, I don't remember if it's 1 categorical and 1, I think it's 1 and 1, one of each type. And you're going to talk about those. So if it's categorical, you're going to pick the appropriate display. And you're going to talk about independence. And you're going to talk about distributions, all that kind of jazz. Okay? So maybe in a second I'll give you a chance to go on Canvas to do that. Actually, let's do that. Why don't you guys, if you have your phones, why don't you do that? And also notice that you do have a quiz on Chapter 2 next class. Because that's it. That's all of Chapter 2.